Okay, so one thing we want to do is we want to use a rule when we're solving radical equations. So when you're solving radical equations, it's difficult for you to be able to know what to do in order for you to solve a radical equation. So basically, solving a radical equation means you're solving an equation that contains a radical, is essentially the problem. So I have the square root of x equals 4. So when I'm solving, my goal is to isolate the variable on one side. Well, I have the variable isolated, but it's under the square root. So this doesn't really help me. So when you're solving radical equations, you do want to isolate the radical on one side. So this is good because my radical is isolated. So you isolate your radical on one side of your equation. The next thing is that you're going to raise both sides of the equation to the power that matches the radical, that matches the index or your radical root. Okay, so this is the nth root of a raised to the nth power is automatically going to give you a. So basically, if we're looking at the square root of x equals 4, we're trying to identify what value of x can go under there and create a true statement, right? So we're not going to work backwards. We're just going to use the process in order to do this. So the process says isolate the radical on one side. That's done. The second step says raise both sides to the power that matches the index or radical root. So this is a square root. So in order for me to do this problem, I'm going to raise both sides of this equation to the second power. So the square root of x raised to the second power is just x. Because what is it in long term? Long ways, the square root of x squared means square root of x times square root of x, which means the square root of x squared, which means x. And so this rule is basically telling you it is the definition of the radical. The radical, any radical root raised to its matching exponent is always going to cancel each other out and give you just what's under the radical. So the square root of x squared just yields me an x equals 4 squared gives me 16. Well, this problem is solved because then your next step is solve. So once you've gotten rid of the radical, you should be able to solve your problem accordingly. And in this case, I'm done. So when we check, square root of 16 equals 4. Yes, true statement. I did it correctly, right? So when you're solving your radicals, you should always check, 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 check. Okay? All right, let's look at another one. Let me erase this. Square root of 8x minus 1 equals square root of 1 minus 8x. So we have two radicals here. So they're each isolated, so we're good there. So then we're going to raise both sides to what? The second power, because they're both square roots. Which you have to have the same radicals in the equations. They're not going to give you a cube and a square in one problem. Don't worry about that. So 8x minus 1 equals 1 minus 8x. Now, this is just a basic equation. This has nothing to do with this chapter, really, right? Now we're in prereq. We're in beginning algebra at this point. This is a basic equation that we should be able to solve. I'm going to get my x terms together. Get my ones together. Divide both sides by 16. X is equal to 2 over 16, which reduces to 1 over 8, and I'm finished. And you can plug that into the original problem to check, which is what you should do. You should always check to make sure your solution works out. All right, let's look at another one. Cube root x minus 6 minus 4 equals 0. So here we have the cube root of x minus 6 minus 4 is equal to 0. So remember the first rule says what? Isolate the radical on one side. So in this particular example, the radical is not isolated because there's a 4 that's still over there with it, but it's not under the radical. So the 4 is going to relocate. So I'm going to add 4 to both sides. Okay, now since my radical is isolated, I can figure out what power I'm going to raise it 2 on both sides. So if it's a cube root, because it has cube root of x minus 6, I'm going to raise both sides to the third power. So when I do that, the left side, the radical and the exponent cancel each other out, equals 64. I'm trying to solve for x, which means isolated, so I add 6 to both sides. X equals 70. Problem is done. We can always check. So the cube root of 64 minus 4 equals 0. Cube root of 64 is 4. 4 minus 4 is 0. Does 0 equal 0? Yes. So we know we did it correctly. All right. All right. Let's look at this other one. All right. So for this particular problem, the radical is not isolated. So I need to isolate the radical. So this x in front, the radical is going to have to move. So I'm going to minus x on both sides. So I get negative square root 1 minus x equals negative x minus 11. So what we're going to do is we're going to get rid of this negative in front of here. So I'm going to divide both sides by negative 1. So square root of 1 minus x equals x plus 11. So I just divide each term by negative 1 because you don't want your square root to be negative. We would just want it isolated positive. It's easier to get rid of it now. So then I'm going to raise both sides to the second power. So the left side, square root of 1 minus x squared is just 1 minus x. And then the other side, x plus 11 squared. Please, 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 please make sure you understand there is no rule other than the basic rule of x plus 11 squared means x plus 11 times x plus 11, right? There is no radical here, so you can't just bring down the x plus 11. The square root cancels with the exponent 2 on the left side. There is nothing to cancel the exponent out here, which means you must go through your operation. X plus 11 squared means x plus 11 times an x plus 11, which then must be distributed through. My goal here is to solve. But when I look at this problem, I have an exponent, x squared there. What's that mean? That means I'm going to have to solve this by factoring it, because I can't just try to isolate x because there's a squared term present. So I'm going to get all of my problems, all of my terms on the same side of the equation. So I'm going to move my x and I'm going to move my 1. So I got x squared plus 23x plus 120. So let's factor. So I need factors of 120. That'll give me a 23. All right, so I had to use my calculator to go through the list. So when I go through my list, I get 15 and 8. So plus 15 plus 8. So x. So I said each factor equal to 0. I get negative 15 and negative 8. Now, this is a perfect example where we have to check. Anytime you get multiple outcomes, you should definitely always check. So my check. The original problem so negative 15 minus 1 plus 15, negative 15 minus square root of 16, negative 15 minus 4, negative 20. So these don't equal each other. So negative 15 does not look like a solution. So then negative 8 minus 1 minus negative 8 equals a negative 11. So negative 8 minus, remember a solution means a value that can be substituted in and create a true statement back. Negative 11 equals negative 11. So we got it. So the only outcome you can use is that x equals negative 8. That's why checking is so important on your radical equations, because it is most likely that you are going to get what is called an extraneous solution, something that must be thrown out. Okay? So just make sure that you always check your outcomes, especially when you get multiple options. Especially when you get multiple options. Okay? And that is solving equations that contain radicals.